Hi class, in this video we work example 3 in your note packet on implicit differentiation. It's called section 3.6. And the equation that we're going to differentiate is via implicit differentiation is y squared plus x squared plus x times y is equal to 7. Now, in this equation, remember y is a function of x. So we have x times y, and so we have a product here, two functions of x and y. And so when we differentiate that product, we're going to have to use the product rule from the rules of differentiation back on page 22 in your note packet. Okay? And so this, implicit differentiation is giving you a good opportunity to review some of those basic rules of differentiation. And so remember from the product rule, basic rules of differentiation, if we have a product of two functions, right? F is the first function, S is the second. Then when we differentiate that product, right, the form of the product rule we've been using is the derivative of the first function times the second function plus the derivative of the second function times the first function, okay? Now there are other forms of the product rule, right? You can switch the order of multiplication and you can switch the order of addition. Okay? But this is, when we talked about the product rule back on page 22, this was the form of the product rule that we used, okay? So here's our equation, y squared plus x squared plus xy, okay? So x is the first function in that product and y is the second function in the product. That's important to keep in mind, okay? So, remember we can differentiate by the sum and difference rule, right? We can differentiate these terms, right, term by term. So when I differentiate y squared with respect to y, right, I bring the 2 down in front of the y, subtract 1 from the exponent, I get 2y. And because y is a function of x, I got to multiply that by dy over dx by the chain rule. The derivative of x squared with respect to x is just 2x by the product rule. Now we got to differentiate x times y. X is the first function, y is the second. So from our form of the product rule over here, right, the derivative of x is just 1. Then we multiply that by the second function, y. And then we add to that the derivative of the second function. Well, y is the second function. And the derivative of y with respect to x we denote with dy over dx. And then we multiply that by the first function, x. Okay? So this, okay, 1y plus dy over dx times x is the product of x times y using the product rule. Okay? Now we got to isolate dy over dx on the left-hand side of the equal sign because we're solving for dy over dx, right? We're finding the derivative of y with respect to x. So at this stage now it's all algebra, okay? So the first thing we're going to do is we're going to keep each term with dy over dx, right? Derivative of y with respect to x on the left-hand side. So we have 2y dy over dx, that's right here. And then we have dy over dx times x, that's right here. I switched the order of multiplication, made it x times dy over dx. Then I took the plus 2x and the plus y, and I moved them both to the right-hand side via subtraction. I subtracted 2x from both sides, and I subtracted plus y from both sides, right? So minus 2x and minus y, okay? And that's how I ended up with minus 2x minus y on the right-hand side. Well, now we have a sum, and dy over dx is a common factor, right, in these two terms. So I can factor out the dy over dx, right, on the left-hand side. And when I factor out the dy over dx, what's left in parentheses is 2y plus x. How do I verify I factored that correctly? I can distribute the dy back inside the parentheses, and I'll end up with this up here, okay? So I factor out the dy over dx on the left-hand side, And now I have a product. I got isolate dy over dx all by itself on the left. What undoes multiplication? Division. So I divide both sides by what's in parentheses here, 2y plus x. And when I divide both sides by 2y plus x, this goes away. And on the right-hand side, I'm left with minus 2x minus y from up here, divided by 2y plus x. And we're done. We have the derivative of y with respect to x.